Hi students, this is the second example that I'm going to run through of graphing a linear inequality. And again, I'll kind of talk through not just the steps, but why I'm doing the steps as I work my way through. And you can follow along and try this on your own. So here's the inequality that I'm going to graph. Y is greater than 1/2 x plus 5. So again, just like in the first example, in the first video that I looked at, this inequality is in slope-intercept form. Y is by itself on one side of the equation. 1/2 x tells me that 1/2 is the slope, and the 5 is the y-intercept. So I'm going to use that information to mark a couple of points on the graph, starting with the y-intercept at y equals 5. So put that in there. Slope is already in fraction form, so from there I'm going to go up one space and 2 spaces to the right. And I'll do that a couple more times. And all the way over to the edge of the graph there. And then I could also think of that 1/2 as being -1 over -2. So I'll go down 1, 2 spaces to the left. I'm going to mark in some points in the other direction. And that'll look like that. Okay, so before I connect these points together, this is where I'm going to take a look at my equation, and I'm going to decide, do I want to use a solid line or a dotted line to connect them? And so what I'm looking at is, with the inequality symbol, change to a different color here. With the inequality symbol, if I have an equal part, so remember if it's less than or equal to or greater than or equal to, I'm going to use a solid line. If there is no equal part, meaning that the points that are right on the line don't actually make a true statement, then I'm just going to use a less, well then we have just a less than or just a greater than. I'm going to use a dotted line to connect them all together, or a dashed line. Okay, and I can double check this because, again, if I take a look at the y-intercept, so that's the point 0, 5. If I plug in 0 for x, so I say 1/2 times x, or 1/2 times 0 plus 5, and I plug in 0 for y, and, or sorry, if I plug in 5 for y, I put in my greater than sign, and I simplify this, what I get is that 5 is greater than 0 plus 5, or in other words, 5 is greater than 5. And that's not really true. 5 is not greater than 5. 5 is equal to 5. And so that tells me that these points that are right on the line are not actually solutions to this inequality. They're the boundary for the solutions to the inequality, but those points themselves are not solutions. And I could actually double check that with another point. So like say that I chose, I've got another point over here at 2, 6. If I put in 6 for y, and I put in 2 for x, okay, that means I'm going to take 1/2 of 2, or 1/2 times 2, which is 1, plus 5. And again, I'm going to get 6, but 6 is not greater than 6. 6 is equal to 6. So again, this isn't really a solution. It doesn't really make a true statement for this inequality. So what that tells me is that I need to connect these points together with a dashed line. And so I'm just going to work my way along here, and I'm going to connect all of these points along this line with a dashed line. Still going to put arrows on the ends. Okay, and I still want it to look nice and straight, and I still want it to go all the way across the graph, just like when we draw it in a linear equation with a regular line. Okay, So then, if you remember from the first video, we said that the next thing we have to do is we need to take into consideration the fact that what we're looking for here are all the values of y that are greater than 1/2 x plus 5. And so you might sort of logically say in your head that, okay, that means that we need to shade in everything that's above the line. And we're going to double check that in just a second here. And again, you kind of want to be careful because if there's negative signs or anything in your equation, that can actually, sort of reverse things. But again, what I'm going to do is I'm going to pick a test point, and I'm going to test 0, 0. And I'm going to see if I plug in 0 for x and 0 for y, do I get a true statement, a true inequality? So I'm going to plug in 0 for y and 0 for x and plus 5 and see what I get here. So 0 is greater than 1/2 times 0 is 0 plus 5, and that gives me 0 is greater than 5. That is not true. And so what that tells me is that 0, 0 is not a solution to this inequality. It should not be in the shaded section of my solution. And so when I go to shade this in, I'm going to shade up above the line that I drew in. And again, this doesn't have to be perfect, but I'm just going to get as close as I can here and kind of shade in the part of the graph that is above the line. Okay, and that's it. That is the solution to the inequality. Everything that is in that shaded region is a solution to this particular inequality. And that's the end of this example. So I'm going to do one more video with one more example. You can look for that down below. And I will see you later.